So today's topic is conversion of infix to postfix. Then how to evaluate a postfix expression. These are the two topics we will cover today. So first of all, we already know how to convert an infix expression into postfix. To convert an infix expression into postfix, how to read the characters from the infix expression. If the character is an operand, push the if the character is an operand, output the character. If the character is open parenthesis, push the operator into the stack. If the character is operator, then check whether the stack is empty or not. If the stack is empty, push the character into the stack. If the stack is not empty, check the priority. If the priority of the operator greater than the operator priority, then so push the character. Otherwise, pop the characters and then push the characters. If it is a closed parenthesis, pop the characters up to open parenthesis. So this is the procedure for to convert an infix expression into postfix. I will write some algorithm. So it's not a complete complete implementation. It's an algorithm. So return type is what. So function I will write infix to. This is the function. So we have the character char infix of. So this is the infix expression. So we take the infix expression as a character infix to postfix. So I will take the entire expression as a string. So if it is a string, we read the characters from the first position for I equal to 0. The infix of I not equal to null character. So we'll read the characters from first position for I, that's way for I equal to 0. Infix of I not equal to null character. So I press means the total infix expression will be treated as a string. That's way. So then we go for the procedure. First, if it is an operand, if infix of I greater than or equal to A and infix of I less than or equal to Z. So if it is greater than or equal to A and less than or equal to Z, that means if it is a character. If it is an operand, so output the character. So we have to print or see out infix of I. So if it is a character, so yes. Infix of else. So if it is not a operand, if it is not an operand, check whether it is an open parenthesis or not. If so, if it is first of all, I will check operator. If it is an operator, so what are the operators? If infix of I is equal to plus or infix of I is equal to plus minus or infix of I is equal to star or infix of I plus minus star slash. So if it is a operator. So if it is an operator, check the priority, please. మూడైతే ఇంకా బాధ్యతలు అయితే మూడు ఇంకా తేరీ తేరీ అంటున్నారా నువ్వు ఎగ్జాంపుల్ నీకు అది ఒప్పిడి తెలుసు నేను పడుకోవాలి కారణం ఏమని చెప్పు ఆ మ్యాటర్ చెక్కింగ్ ఉంది కదా చూసుకోమంటున్నాను. So if it is an operator, so operators are, we are taking only plus minus star slash. So if it is an operator, check the stack. If top is equal to -1, if top equal to -1 indicates the stack is empty. If the stack is empty, so you have to push the character, push infix of it, push stack comma infix of it, push the character into the stack, else. So if the stack is not empty, if the stack is not empty, then check the priority. If priority of infix of I greater than priority of stack of top. So if it is a operator, then check if top is empty or if stack is empty. If stack is empty, push into the result. If stack is not empty, so if check the priority. If the priority of the infix of character is greater than priority of stack of top, then push the character. Push stack comma infix of it. Else. So if it is an operator, stack is not empty, so priority is not greater than. So in this case, you pop while ch equal to pop y. While stack of stack of top less than or equal to priority of infix of I. So then stack comma. So this is the operator. So what is the procedure? So I've taken total expression as a string. If I taken total expression as a string, so that string I called as infix of I. Infix. So we have if it is a string, we have the characters from 0 position, and the string will be terminated with null character. So for I equal to 0, I less than I not equal to infix of I not equal to null I plus plus. If infix of I greater than or equal to A and infix of I less than or equal to Z. If it is greater than or equal to A and less than or equal to Z, then output the character. So that means if it is an operand, else. If it is an operator, so what are the operators? Plus, minus, star, slash. If it is an operator, if the stack is empty, so when the stack is empty, top equal to minus 1. If the stack is empty, push the character into the stack. Else. If the stack is not empty, check the priority. If the priority of infix of I is greater than priority of stack of top, then push the character into the stack. Else, if the stack is not, if the stack contains some operators and priority is not greater than top of the stack, so in this case, so pop the operators from the stack. So less than or equal to, if priority of stack of top, priority of stack of top less than or equal to priority of infix of I. So priority of infix I have. So you have to pop the operators from the stack and print it. Finally, push the character into the stack. So else. Else. So here else means if the character is not a operator, then we check if infix of I is equal to open parenthesis. So if infix of I is equal to open parenthesis, push stack comma infix of I. Else. Yes. So if it is not a open parenthesis, then check it is a closed parenthesis. If infix of I is equal to closed parenthesis, if infix of I is equal to closed parenthesis, so if it is a closed parenthesis, then pop the characters up to open parenthesis, while ch equal to pop from the stack not equal to open parenthesis, then of ch. So this is the process. So this is the one we are using to convert an infix expression into postfix. So let us assume that the total infix expression will be treated as a string. So if it is a string, the first position is 0. All the strings are terminated with null character. That's why if it is an object, whether it is an operand or not. So when we say that it is an operand, if greater than or equal to A and less than or equal to Z, if infix of I greater than or equal to A and less than or equal to Z, then print the character. So output. Else, if it is an operator, what are the operators? Plus, minus, star, slash. If it is an operator, then check stack is empty or not. If top equal to -1, indicate the stack is empty. Push stack comma infix of I. Else, if the stack is not empty, if it is an operator, stack is not empty. So check the priority. If priority is greater than push. Else, pop and print. So if it is an open parenthesis, push the character. If it is a closed parenthesis, pop up to open parenthesis. So this is the procedure to convert. Finally, we have to print while top not equal to -1, ch equal to pop at, then c of ch is the procedure. So like this, we convert an infix expression into postfix. This is the procedure to convert an infix expression into postfix. So like this, this is the algorithm. So it's not a total program. So it's an algorithm. So this is the procedure to convert an infix expression into postfix. This is the process. Then we go for next topic, evaluation of postfix expression. So how to evaluate postfix expression. So what is the procedure? So we already know that what is postfix expression. How to evaluate the postfix expression? So the procedure, what is the procedure? The procedure to evaluate postfix expression is how to evaluate the procedure. If the character is an operand, the character into the stack. So if it is an operand, push the character into the stack. If the character is an operator, pop two operands from the stack and evaluate operator and push the result into the stack. Repeat steps 1 and 2 until expression completed. So this is the process. So what is the procedure? So check. So if it is an operand, push the character into the stack. If it is an operator, pop two operands from the stack, evaluate operator and push the result into the stack. So this is that. So we have to repeat the steps 1 and 2 until expression is completed. So this is the process. Suppose I will take one example. So we have so many postfix expressions are there. So we'll go for one example, postfix expression example. For example, this is a infix. This is the postfix. So instead of A, so A value is 5 and B value is 6 and C value is 3. Let us assume 5, 6, 3 star S. So like this. So otherwise A, B, C. So A value is 5, B value is 6, C value is so like otherwise we make it as so somebody will write like this. So step 1. Read 5, push into stack. So what is the first statement? Read 5. So read 5, push into the stack. First statement. We have the read 5. First character is 5 and push the 5 into the stack. So when we push the 5 into the stack, then the stack is like this. So it is 5. So I will push 5 into the stack. Step 1. Step 2. Read 6. Push into stack. So next is fix 6. So then the stack is like this. We have the stack. Then the stack is like this. 5 after 6. So again, step 3. Read 3, push into. So what is? So we have to push 3 also into the stack. Next. What is the next character? Read star. So if it is a star, push pop 2 operands from the stack and pop two operands from the stack. It is a star, pop 2 operands from the stack. So this is a stack. So when I pop 2 operands, so pop 2 operands. What are the 2 operands? 6 and 3. So and evaluate 6 into 3, 18. So push the result into the stack. Now the stack is 18. So if read star and pop to read star, comma, pop 2 operands from the stack. So pop 2 operands from the stack and evaluate star. Evaluate star. So this. Then what is the next step? Step 5. So what is the next character is plus. Read plus. Pop. So it is an operator. So pop 2 operands from the stack and evaluate plus 15 plus 8. What is the result? 23. So then the result is 20. So 20. So therefore, the result of the expression. So like this, so we can evaluate an infix expression into postfix. So this they will give the one expression. So you read the characters from the expression. If it is an operand, push the operand into the stack. If it is an operator, pop 2 operands from the stack. So evaluate and push the result into the stack. Pop 2 operands, evaluate from the stack, evaluate star and push result into stack. Same. So it's here also. Push result. So this is the way to convert an infix expression into postfix. So we'll go for another example. Suppose I will take this expression. evaluate 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 AB star CD slash plus. So ఇక్కడ the continuation ఇవ్వచ్చు కదా. Let us assume A equal to 5, B equal to 6, C equal to 1, D equal to C equal to 2, D equal to 1, and so this is the expression. So like this is the expression. So and then so A value is 5, B value is 6, C equal to 2, D equal to 1. So I evaluate. So the postfix expression after substitute values. So what is the A value? 5. What is the B value? 6. Star. What is the C value? 2. What is the D value? 1. Then slash. Then plus. This is the expression. So we'll go for step 1. Read 5 and so we have to read 5 and push into the stack. So when we push into the stack, so then the expression is this step 2. Okay. Step 2. So what is step 2? 6. Read 6. Read 6 and push into. So then the stack is sorry. So then it is 6. 6. What is step 3? What is step 3? Read star. So restart. So అప్పుడు ఏం చేస్తాము? Pop 2 operands from the stack evaluate star and push this. So if it 5 and 6 is 5 into 6, 30. So push the result 30 into the stack. Yes. Step 4. What is step 4? So to read 2. So when I push into stack, so it is 30. So and the next value is 2. Step 5. Read. So what is read? 1. Read 1 and push into. So then the stack is so we have the 30, 2, 1. Step 6. What is the next character? Slash. Read slash pop 2 operands from the stack. Pop 2 operands from the stack and push the result. So then the stack is we have the 30. So 2 by 1. So 2 by 1 means then the result is 1. So when we divide the 2 by 1, so 1 2 again the result is 2. If you divide by number by 2, so it's 1. Again we have the step 7. What is step 7? Read. So read plus. So read plus pop 2 operands from the stack and push the result into the stack. So 30 plus 2, 32. Then the result is 32. So next, what is the operator? No operator. So therefore, the result of the expression is 32. So like this, we convert an infix expression into postfix. So this is the way to evaluate a postfix expression. So this is the process. So to evaluate any postfix expression, so these are the two. If it is an operand, push. If it is an operator, pop 2 operands, evaluate and push the result. So we are taking the input as a postfix expression. A postfix expression cannot have parentheses. You take any postfix expression, the postfix expression cannot have parentheses because we are removed. And we are removed, we are arranged. So this is the way to convert a postfix expression. This is the way to evaluate a postfix expression. So like this, we convert an infix expression into postfix. This is about evaluation of postfix expression. So next we go for next topic. Is there any? Then we will discuss. Otherwise, we'll go for next unit tomorrow. So actually, we will see the syllabus. Yes. This is the data structures. We are in third unit. So this is third unit. Introduction to queues. Representation of queues using arrays. We are already discussed. So using linked list also we are using queues using linked list. Implementation of queues using arrays and linked list we are already discussed. Applications of queues. In applications we have the circular queues as covered. Double-ended queues covered. Priority queues covered. Multiple queues not covered. I will tell you. Okay. So again, go for stacks. Introduction to stacks. Okay. Array representation of stacks we are discussed. Operations on stacks. Okay. Linked list representation of stacks covered. Operations on linked list. Okay. Operations on linked list. Okay. Covered. Applications reverse. So we are already discussed reverse a list. Already we are already discussed how to reverse a list. Factorial calculation, we know how to calculate the factorial using recursion. Yes. Infix to postfix conversion. Yes. Evaluation of postfix expression. So these are the different. This is about third unit. So we have that we have covered all the topics except multiple queues. We are all covered all the topics. This is about the third unit. So like this, you have to verify. You can verify your syllabus with respect to the topics covered by the teacher. If not covered, you can ask me. So this you have to take this PDF copy. So which is available in site also. So and verify the topics with respect to the teacher who taught the units. So if it is covered, so like this, you have to cover each and every win because we have the internal choice questions. So for each unit, the students must know all the topics because so unit 3 question has the choice of unit 3, unit 4 has the choice of unit 4. So we have there is no total choice. Each and every student must learn all the units because so at least of 3 to 4 units is necessary. Otherwise you can't. So again after that we discuss 4 and 5 units. So tomorrow we discuss multiple queues. After discussion of multiple queues, so we'll go for next topic, unit 4, binary trees. Then we go for graphs. This is about third unit syllabus. So we have only one more topic is pending, multiple queues. I will cover tomorrow. I will cover the multiple queues. So then later we discuss binary trees. What is a binary tree? So what are the properties? How to represent the array representation, linked list, binary search tree, concepts, each and everything we discuss. No problem. So we discuss some chart there. So first unit we have the Fibonacci search. Yes, we have the pending is there. So in first unit we have the one topic is pending, Fibonacci search, and the remaining is also covered. In the second unit I covered, I think in first unit we have the definition, data structures, operations on data structures, abstract data types, preliminary algorithm space and time complexities, linear and binary search covered, Fibonacci search is not covered. Insertion sort, selection sort, bubble sort, quick sort, radix sort, merge sort, everything is covered except Fibonacci search. So I will explain. Okay. In second unit we have the linked list, single linked list, representation of linked list in memory, operation linked list, insertion, deletion, search, traversal. Traversal means display. So if it is a traversal, the traversal means display. Traversal single linked list, I already told. Application of linked list, polynomial expressions, representation of polynomial, addition of polynomial, multiplication of polynomial, sparse matrix representation using linked list. Okay. So I explain using arrays. Okay, I will explain representation, sparse matrix representation using linked list. Advantage and disadvantage of single linked list, double linked list, insertion, deletion, circle linked list, insertion and deletion. We have one more topic actually I covered, but sparse matrix representation using array I told, but here the syllabus is sparse matrix representation using linked list. Okay, I will explain how to cover. This is one topic pending in second unit. First unit we have the Fibonacci search. Second unit we have the sparse matrix. I covered sparse matrix, but so I explained sparse matrix using arrays. But here the sparse matrix using linked list. Okay, I will explain it. So then we have the total third unit, except multiple queues. The total topics are covered. Then we go for this fourth unit. So tomorrow I will explain multiple keys. Then I will go for multiple. So students can write the notes from verifying the YouTube channels and write your own. So there is no separate notes because separate notes ఉండదమ్మా ఇక్కడ నేను చెప్తుంది చూడండి అమ్మా బాగా యూనిట్ మీకు ఫస్ట్ ఇయర్ లాగా ఉండదమ్మా ఇదంతా టెక్నికల్ పేపర్స్ లో అన్ని మీరు అనుకున్నట్టు ఫస్ట్ ఇయర్ లాగా ఉండదు ఏదో మ్యాథ్స్ ఫిజిక్స్ కెమిస్ట్రీ లాగా ఉండదు సో టెక్నికల్ పేపర్స్ అంటే చాలా ఇదిగా ఉంటుంది అందువల్ల